we're doing shell method. And we got f of x and g of x, where f of x is greater than g of x. So if I make a quadrant here and just let's say f of x is the green one, g of x is the red one, so f of x is greater than g of x. And so we get a region that would look something between A and B. And we're going to rotate this around x equal -1. And we're doing shell, so our slice would be parallel to the axis. So it would be a slice here that would go round and be over here. Its thickness is in the x direction, so it'd be dx. And it'd be the integral, and the shell methods, it's 2 pi r. Well, r is from here to there, but from here to there is an x value plus one more unit. So it'd be x plus 1, that's the r, 2 pi r. So that's the distance around times the thickness times the height. And the height is this height is just f of x, and this this height is g of x, and we want to take the g of x away from the f of x to get just that height of the ring. So we should have in our integrand x plus 1 times f of x minus g of x. That's not this one, that's this one. There we go. 33. 9 minus x squared. Let's see, that would be an upside down parabola pushed up 1, 2, 3, 4, 5, 6, 7, 8, 9. Going down. And on the interval 0 to 2, in the x direction, and we're doing it about the x-axis. So this about the x-axis would be something down here. We're doing shell. So if we're going about the x-axis, we'd have to do a slice parallel to the x-axis. Well, I usually do that in red, so let's do that here in red. So the thickness of that slice is d, it's in the y direction. Integrated from 0 to 9. But we can see their symmetry here. So let's just use this half of this disk, whatever, and double it. And so we got to do 2 pi r. The radius is up is y. 2 pi r. That's the distance around, times the thickness, times the height. Well, that is x. If I stayed to just this side and double it, that's just x. But what is x? So we would have to solve this for x. So it'd be y minus 9 is negative x squared. So 9 minus y equals x squared, multiplying by -1. Then I would take the square root. And that's how we get this side and that side, because it would have been plus or minus, but we're only doing this side, so we can just leave it that. So we got 2 pi 0 to 9 y and x, which is the square root of 9 minus y dy. Okay, how are we going to do this, ladies and gentlemen? All right, so I'm going to let u equal 9 minus y. Du would equal minus 1 dy. So dy can be replaced with du over negative 1, or negative du. So I'd have 2 pi, new limits. Oh, I'm not going to get a y to cancel. So let's see, what is y? Well, if I solve this for y, I add y, subtract the u, y would equal 9 minus u. So y is 9 minus u times the square root of u, and dy is negative du. Okay. Distributed this u to the 1/2, and so I get negative 2 pi, some limits, of 9u to the 1/2 minus u to the 3/2 minus 2 pi. 1/2 plus 1 is 3/2, and divided by 3/2 is times 2/3 times 9u to the 3/2 minus 1 added to 3/2 is 5/2, u to the 5/2 divided by 5/2, or times 2/5. Evaluated from don't know to don't know. Could go back and figure that out. Let's figure those out, and so we can just do this. So y went from 0. Let's see, where's the u? Right here. Y went from 0, 9 minus 0 is 9, to 9. 9 minus 9 is 0. So there's my new limits. So if I put u0 in for all the u's, I get nothing. So I got minus 2 pi times 0 minus a minus 2 pi times what I get when I put 9 in there. 9 in here, take the square root, that's 3 cubed is 27. Divided by 3 is 9, so I get 9 times 9, 81 times 2 is 162, minus the square root of 9 is 3 to the 5th is 243 times 2 is 486. This is nothing. So 5 goes into 45, 9, leaving 4, 9, and 1/5. So I got 162 minus 99 and 1/5. So that'd be 62 and 4/5 times 2 pi, which would be 125 and 3/5. 125 and 3/5 pi, I believe, if I didn't make a mistake in my arithmetic. Okay, 36. Shell about x equal negative 3 minus 1, 2, 3. Region A. So if I'm doing shell, I slice parallel to the axis, so I'm going to slice it this way. So it's going to be dx, and it's going to be 2 pi r. Well, this is x, but this is 3 more, so it's x plus 3, 2 pi r times the height. Well, that height is 6 minus that, which is that. So the height is 6 minus x squared plus 2. 2 pi r times the height times the thickness. Integrated from 0 to 2. All right, so we get 6 minus x squared, so that's 6 plus minus 2, that's 4 minus x squared, x plus 3. So we get 2 pi 0 to 2 negative x to the third plus 4x plus minus 3x squared plus 12 plus dx. They're all in terms of x, which is what we need. So we can just integrate 2 pi negative x to the fourth over 4 plus 2x squared minus x to the third plus 12x, evaluated from 0 to 2. And 0 is going to create nothing, so it's all going to be from this 2. 2 pi. 2 to the fourth is 16 divided by 4 is 4. 2 squared is 4 times 2 is 8. Minus 8 plus 24. Minus 4 plus 24 is 20 times 2 is 40 pi. Okay, 6-4. Region A, shell method about y equal minus 2. 2, 0, minus 2. Shell method, slice it parallel to the axis. Thickness, therefore, is this way, which is dy. We're going to integrate from 2 to 6. 2 pi r, r would be y, plus 2, because we're down 2 to here. So y plus 2, and the height would be this, which is just x. X by 2 pi r times the thickness. So all we have to do is get the x out of there. What do I replace x with? Well, that would be subtract 2 and take the square root. So this is 2 pi 2 to 6 y plus 2 times the square root of y minus 2 dy. So if I let u equal y minus 2, du equals dy, and I get 2 pi. Pretty easy to change the limits on this. 2 minus 2 is 0. 6 minus 2 is 4. Y plus 2. Y would be u plus 2 equals y. So I'm going to put u plus 2 because I'm not going to get that to cancel. So y becomes u plus 2 plus another 2 is u plus 4. Square root of u. Du is dy. So multiply that in, and I get 2 pi 0 to 4. U to the 1 times u to the half is u to the 3 halves plus 4u to the 1 half du. So we got 2 pi 5 halves divided by 5 halves is 2/5 u to the 5 halves plus 3 halves 2/3 times 4u to the 3 halves from 0 to 4. Okay. So that's 8/3, but we'll just put this, putting in 0 is going to create nothing. So we got 4. So we got 2 pi, square root of 4 is 2 to the 5th, 32, 64 fifths, 64 fifths, plus square root of 4 is 2, cubed is 8, times 2 is 16, times 4 is 16 times 4 is 64 thirds. And that would be what we get here. So we'd have to multiply by 3 of these and 5 of these. 3 times 5 is 15. And so 3 64s plus 5 64s is 8 times 64. 64, 128, 256, 512 fifteenths times 2 pi, which is 1024 fifteenths pi. If I didn't make any arithmetic errors. I'm going kind of fast, so highly possible. Either method. This about y equals -2. That's down here. So we can do disk or shell. Let's do disk to start with. So I slice perpendicular to the axis. So the thickness is dx. It's going to be integrated from 0 to 2. And the disk is pi r squared. R is y plus 2 quantity squared. Pi r squared times the thickness. Yeah, that's it. And you can do a u substitution, or this is pretty easy. That's going to be pi. Integrate that. It's going to be y plus 2 to the 3rd divided by 3. The derivative inside is 1, so that's not going to create anything extra. Evaluated from 0 to 2. Oh, wait a minute. This is x, this is y. Blah. I got to get that out of there. I thought there had to be more here. See, what was this equation again? Y equals x squared plus 2. So we got to replace that in here. So this becomes pi integral from 0 to 2 of x squared plus 2 plus 2. X squared plus 4 squared dx. Now it's in terms of x. Now I can integrate, except that this is not an easy one to do in our head, so we better square this. That would be x to the 4th plus 8x squared plus 16. So we're going to have pi, that integrated is x to the 5th over 5. That integrated be plus 8x to the 3rd over 3 plus 16x evaluated from 0 to 2. Oh, ugly, ugly, ugly. Okay. Really challenging me here with all these fractions. 32 fifths. 8 times it's 64 thirds plus 32 minus 0. So pi 6 2/5 plus 21 1/3 plus 32. 6, 27, 39, 59 plus 2/5 plus 1/3 pi. That's 6/15 and 5/15 is 11/15. 59 11/15 pi. Okay, let's do it again using the shell method. Let's see how that works. Let's see, so we're now slice parallel. So we're going to have to do this in 2 pieces. It would go from up to there, and then it starts getting smaller. So it will be a thickness of dy. So we're going to have to do it in 2 pieces. We're going to integrate from 0 to 2 for this. That's going to be pretty straightforward. Plus the integral from 2 to 6. Shell method is 2 pi r. The radius for these inside is it's y up plus 2. The height is always 2. 2 pi r times the height times the thickness. That would be this first up part of it going around. The second part would be same thing, 2 pi r, which would be y plus 2. But now the height is not always 2. It's 2 minus that, which is x. 2 minus x. This one's straightforward. The 2 comes out, and we get 4 pi integral from 0 to 2 of y plus 2 dy. That's easy enough to do. This one, we got to replace the x. So we have to solve for x. So that would be y minus 2 equals x squared. Subtract, or take the square root, and so we got the square root of y minus 2 is what x needs to be replaced with. So we got plus 2 pi 2 to 6 of y plus 2 times 2 minus square root of y minus 2 dy. And I'm thinking this is probably easier to do it that way. Let's see. Okay, this part should be easy. And our goal of this is going to be 4 pi y squared over 2 plus 2y evaluated from 0 to 2, which is going to give us 4 over 2, 2, plus 4, 6, 24 pi. The 0 gives us nothing. That one's easy. This one, not too much. 2 pi, 2 to 6, 2y minus y square root of y minus 2. See, minus or plus 4 minus 2 square root of y minus 2. That's pretty simple. This is pretty simple. These are not so simple. And we can do this. Let's see here. 2 pi. This one would be y squared evaluated from 2 to 6. This one would be plus 2 pi 4y evaluated from 2 to 6. And then we've got minus both of these, which are going to be times 2 pi, the integral from 2 to 6 of y square root of y minus 2 plus 2 square root of y minus 2. To do these, I think I would let u be y minus 2 du equals dy. So I would have minus 2 pi I have to replace the y. Y would be u plus 2 square root of u plus 2 square root of u du. So I could distribute that in there and in there, and this would give me 2 square roots of u, 2 square roots, 4 square roots of u, and this would be u to the 3 halves, and that should integrate easily enough. And and this would not be 2 to 6 anymore. 2 minus 2 would be 0. 6 minus 2, 4. Okay. So let's kind of finish this up here. I think 24 pi 36 minus 4 is 32 times 2 is plus 64 pi. This would be 24 times 2 is 48 pi. Let's see. 24 minus 8 is 16, 32 pi. All that minus 2 pi times this gibberish. Okay. This would be u to the 3 halves that we have to integrate. plus 4u to the 1/2. Integrated, this would be 2/5 u to the 5/2 plus 3u to the 3/2 times 2/3, which should be 8/3. That evaluated from 0 to 4. Square root of 4 is 2 to the 5th is 32. 64/5. Square root of 4 is 2. Cubed is 8. Times 8 is 64/3. And 0 in there is nothing. And if I